Hello, this is the third lesson of the Java course that is joint between STEMEncounters and the Elliptic Collective. So what we're doing today is going over Boolean, if-else statements, and thus ternary operators, mostly operator stuff. And these are incredibly important when you're dealing with Java because oftentimes when you're running a program, you're saying if, say, Sally runs to the mall, then she will be able to get food. If she does not run to the mall, then she will not be able to get food. But those types of statements, you will have to use operators and booleans to help you create this if and if-else statement. So I know Anna talked a little about boolean last time and with a bit of operators, but I just want to go into a little bit more detail. So we'll start with just what her example was last time, which was this. And clearly you're going to get true because 6 is indeed greater than 1. So this greater than sign here is an operator, and these are called equational or relational operators, and you can use any of these multitude of operators in replacement of it. And what is all of this is saying is b is going to be set to the value true or false. It's going to be set to be true if this statement is true, and it'd be false if this statement is false. So a common misconception is when I use not equal to, people will say, oh, it's going to be true if 6 equals 1. But the statement you're considering is not 6 equals 1, if 6 is not equal to 1. So if 6 is not equal to 1, then in fact, b is going to be true. And if 6 equals 1, then b is going to be false. So we can see this is going to turn out as true. So you can play around with any of these. These are pretty self-explanatory. You've definitely seen all of these before. And now I'm going to talk about these arithmetic operators. You have to be very careful with some of these, especially the division one. So I'll just do some examples. So let's take an integer, and if I did 5 divided by 2, you may have noticed from Anna's code that this actually prints out as 2. And the reason for this is because all integers of this form, so Java will automatically quote-unquote round it down. So it will cut off the decimal points after this. So just to explain the math behind this, if I did 5 divided by 2, the natural way you would do it is 5 equals 2 times 2 plus 1. But when you're doing 5 divided by 2, if you take the integer version of it, it would just equal 2. And you won't get 2.5. And another operator you can do is 5% 2, which is giving the remainder, so that will be 1 here. So we're going to see for ourselves. There we go. So that's for integers. So integers, no matter what operation you do here, it's always going to be coming out as an integer at the end, and there's going to be no decimal point. However, if you put a decimal point over here, then Java will actually give you an error because you cannot cast what they call cast a double, which is like a decimal valued number, into an integer. See if I run it here. Then there's an error, and obviously that's going to come out. So now, if we did it with a double, then it would be completely different. So if you did it with a double, then this would actually still give you 2. Let me just change the D. Because these values are still integers. But you would have the 2.0 at the end because it still is, after all, a double. However, if I put 5.0 and 2.0, then I would get 2.5. And when you're doing mixed division, which is if I did this, then it would still actually work out and give you 2.5. The smaller types always going to be converted to the larger one. So the smaller type here is the integer type, and the larger one is the double type. Double type's obviously a lot larger, so it's still going to convert to double. One important thing I want to talk about with division is called typecasting. It's basically forcing the type onto the value, because sometimes I really want 2.5, I don't want 2.0 or 2, then I'm going to be able to typecast it. So if I took 5 over 2, then then what I can do is write double here. So that's going to cast it. So you'll see here, it's going to turn out as 2.5. This is because when you're writing double here, it's making this a double. So what the code does is it does d equals 5.0/2, and as we just saw, this equals 2.5. However, if you did parenthesis here, then what's going to happen is they do the division here first, so you're actually casting 2 into double, which is not what you want. So you always have to make sure you cast one of them into double. So sometimes to make it clearer, you want to put parentheses here. Alright, so now I'm going to talk about unary operators, which are these guys. I'm only going to be talking about these two since they're the most relevant and the most useful. So often when you want to change the value of a variable, what you would do is if I said I equals 5 and I wanted to change it to adding 1 to it, then I would do I equals I plus 1. So that would give me 6. So I could do this anything. I could do like I times I minus 2 times 4 plus 1, and it would give me whatever value that is. So there is a shorthand for increments. Like there's a shorthand for I plus 1, and it is very useful, especially when you're doing loops, which Anna will cover in the next lesson. So the shorthand would be plus I. So this would give you the number 6. So there is another kind of increment called post increment. So this is pre-increment. Pre-increment. Increment, sorry. It's plus I. And this post increment, I plus plus. So when you're doing post increment, this in fact does not give you the number 6. And the reason is that this post increment is actually changing the value of I, like it's adding 1 to I after this line is executed. So this is not very useful at all, especially in our situation, because you're changing the value of I, but you're not actually resetting it. So if I change the value of I to 6 temporarily after I execute this statement, then my I is not actually going to be set to 6. It's just this value is going to be 6 after I execute this. So it does turn out useful in other situations, but typically you always want to prefer plus I, because because usually in general when you're doing plus you want to increment it. So plus I always guarantees that you're going to be able to increment it. So generally try not to use I plus, but of course if you ever come upon a situation will come up, then you may as well just use I plus. The same goes for minus. It's just decreasing instead of increasing. So the final type of operators I want to talk about are these two, and then afterwards this one. So the conditional and, the way this works is that and how do I explain this? So if I had two statements, both Boolean, right? If I had one that could be true or false and one that could be true or false. Say I have statement A and B, and then either of them could be true or false. Like for example, it could be 3 greater than 1 is a statement of A. Then A and B follows a certain thing called a truth table. So if both A and B are true, then A and B will become true. And that is the only situation when A and B is true. So if I have A true, B true, then A and B is true. A true, B false. A and B is false. A false, B true. This is still false. And then lastly, this is true. So it's basically the and because you have to say both of them have to be true for A and B to be true. In a different way, you can do conditional or, which is saying almost the exact same thing, except that A or B have to be true. And when I say or, it's not exclusive or, so they can still both be true. It would be true and true. So we can try an example. So if I had like Boolean B equals this statement and this one. So I had a 6 greater than 1, 6 greater than 1, and then 3 less than 5, 4. Then printing out B. That would give you true. However, if I put greater than, then that would give me false. Right. So that's an example. And this becomes useful. You're probably like, well, why couldn't I just say, if else statement? Well, that gets really complicated. And in fact, you actually use these in the statement of an if-else. So I'll tell you how to create if-else statement. So an if statement will be of this form. It would be if some statement is true. So whatever statement is in here, it's saying if this statement is true, then you execute whatever code is here. So if I say if 3 is greater than 2, then you can say 3 is greater than 2. And clearly this statement is true, so when I execute this, it's going to give me that. However, if I said 3 is less than 2, then this is not going to get executed at all, because 3, of course, is not less than 2. So the place where you start using these conditional operators is in the statement. So if I can say, often you have 2 different conditions for an if statement. For example, I can say if you're going on to go on a roller coaster, you have to be at least 10 years old and you have to be at least 5 feet tall. So it would be like if Sally is 5 feet tall and Sally is at least 10 years old, then Sally can go on the roller coaster. But this is the principle of and. So actually, I'll just create this little snippet to say, and age of Sally equals 5. And height of Sally equals 6 feet tall. Then we can say the age of Sally should be greater or equal to 10, and her height of Sally has to be greater or equal to 5. But this is not true, so Sally cannot go on a roller coaster. So you're probably wondering now, how would I do Sally cannot go on a roller coaster? Because I also want to print something here. I don't want to just leave the the reader hanging. So I can do an else statement. So it's saying all else if this does not turn out true, this entire statement, if I execute this entire statement and it does not turn out true, then else I can do whatever I want here. So I can write Sally cannot go on a roller coaster. And there we have it. So that is how you do if and if else statements. They're pretty simple. And of course you can put anything inside these body statement, like anything here, as long as they're inside the brackets. They're incredibly useful, and you definitely always want to take advantage of your conditional operators instead of having to do another massive if else statement to create a boolean just for this parameter. Alright, so now we're going to discuss ternary operators. And ternary operators are basically identical to if-else statements, except they are a lot simpler and they're just one-liners, but they only apply to certain if-else statements, and you'll see what I mean. So I'll first show you the structure of a ternary operator statement, just so you have a feel for what we're doing, and then I'll give you an example. So this is the structure of a ternary operator statement. Alright, so you're probably wondering what this all means. So this is your variable. So that means, say if I have an integer I. So you already have it equal to 5. So your variable I equals, and we put some expression that gives a boolean output. So for example, you could put 5 is greater than 1. So that could be true or false. And then question mark, 5 and 1. So what this is saying is that if 5 is greater than 1, if this statement is true, then set I equal to 5. If this statement is not true, then set I equal to 1. So in if-else statement format, that means if 5 is greater than 1, then set I equal to 5. Else, set I equal to 1. So what this is basically doing is if expression, and you have I equals value 1, else I equals value 2. So obviously this is a much shorter way to represent an if-else statement. It does seem a little confusing right now, but it literally is just identical to this. There's absolutely no difference when the program is run. The only downside to a ternary operator is that you cannot put a ton of like complex stuff in here. I can't say, oh, print out new stuff, add new numbers, add new variables. You can only do some very simple operations, but it is very useful. So this expression always returns a true or false value, like a Boolean value, and this is what you want to set it to. And sometimes this is kind of useful because especially if you want to take the maximum of two values, then if I have like two integers already, like int v1 equals 3, int v2 equals 0, then I always want to take the maximum. Then I'll say if v1 greater than v2, then I'll take v1. However, if it turns out v2 is actually greater than v1, then I'll take v2. So we can just run it and you see, oh, I should print, sorry. Alright, so this is the bigger one, which is 5, and this is the bigger one, which is 3. So that's all I wanted to cover for today's lesson. This is just a summary of everything we went over. Operators, if and if-else statements, and ternary operators, not really called operations. So I will hand you a short assignment, basically combining all of these ideas together, as well as some of the data types and variable ideas, just to make sure you understand what's going on and able to utilize all the tools you've already learned. And of course, I still recommend that you go online and go to different sites for Java practice. There are tons of them out there. You don't even need a specific site. You can just find exercises on online textbooks and run them yourself and see if you've gotten the right code. Because after all, practice does make perfect, especially when learning a language, because you really need to get used to all the syntax. Yeah, so I'll hand you the assignment, and thanks for listening.